a very nice parametric problem here. They give us both dx dt and dy dt. Part A says find the slope of the line tangent to the path at t equals 4. So we know the slope is dy dx. Dy dx is dy dt over dx dt. They gave us both dy dt and dx dt. And then you're just doing it at t equals 4. So plug a 4 in right there, plug a 4 in right there, and you're going to get that ln of 18 over square root of 17. This is a calculator problem. You can easily plug that into the calculator and get a decimal answer for that as well. Part B says find the speed of the particle at t equals 4, and then find the acceleration vector of that particle. So find the speed. Remember your speed formula on the parametric equation. That's in our blue packet. That's the square root of dx dt squared plus dy dt squared. And it says at t equals 4. So I'm going to take the 4, plug it into the dx dt and the dy dt. And then that's where I'm getting my radical 17 and my ln of 18. I'm supposed to square both of those. And I square that radical, makes that disappear. And then you just plug that into the calculator. That's your speed is 5.035. Reminder, round your numbers at three decimal places. Now, they gave us the dx dt and the dy dt. That is your velocity vector since that's your first derivative. And then they're asking now for the acceleration vector. So we're supposed to take the derivative of those and then plug in 4. Now remember, this is the calculator part of the test. Use the math 8 feature. Math 8 feature with that at t equals 4 gives you the 0.970. Math 8 feature with this one at the t equals 4 gives you the 0.444. Let that calculator do the work for you and get those numbers there. All right, so A and B done. Letter C says find the y coordinate of the particle's position. Now, anytime you want to find a position, you got to always take into account the initial position. So we want the y position at t equals 6, okay? And so we know to integrate the dy dt, that's going to give us the y function, okay? If you look up here, it says at t equals 4, here's where we're at. So at t equals 4, we know the y position is equal to 5. And so that's my starting point. At t equals 4, my y position is 5. So if I know where I'm at t equals 4, I'm going to pick it up right where I left off, and I'm going to go to where I need to go. And so I'm going to go from 4 to 6, pick it up where you left off, go to 6 because that's where you're trying to figure out. And again, when you integrate the dy dt, that gets you your y. So you don't need to actually integrate this stuff yourself. This is the calculator part of the tester. So use the math 9 feature as that as your function on the inside right there. Do the math 9 with that in between 4 and 6, and it'll get you that plus 5, and then you got your 11.571. Letter D is the total distance that the particle travels along the curve. This is your total distance traveled for the parametric stuff. This is like the arc length thing for the parametric stuff. And again, if you forget, that is in your blue packet. That is in your blue packet, the distance traveled right there. It's just the integral of your speed formula. It's just the integral of your speed down there, all right? And so there's your speed formula, you just integrate that. That's my dx dt squared, so I just squared it, got rid of the radical, and then I squared my ln function right there. So again, you integrate the speed, and it just says in between 4 and 6, math 9 that sucker. So please make sure you're practicing that on your own in the graphing calculator. Make sure you can get that number there. The more we practice that, the quicker we're going to be, the more comfortable we're going to be. And it's just going to be speed and comfortability, man. It's going to be good for us. String cheese. Take that in my lunches all the time. String cheese.